Here at the Nebraska Ethanol Board, we get a common question and concern, and usually it goes like this. Well, I've heard that ethanol increases ozone and smog. Is that true? Well, I'm here to say that's not the case. So let's get to some myth busting. It's important to recognize that when we talk about smog, there are two primary factors at play. The first is actually ozone, specifically at the ground level, and the second is particulate matter emissions. Alright, so let's talk about that first component we just mentioned, ozone. Now this is a hot topic during the summer months. There are two types of ozone to cover. The first is good ozone, or stratospheric ozone. It's way up in the sky, and you'll see right up here on the board, it actually would be somewhere above the clouds even. And we've got solar radiation coming from the sun and hitting oxygen in the atmosphere. And it actually breaks the bond. So that oxygen absorbs that energy, and now they will tend to link up with oxygens nearby to form ozone, or O3. This actually protects us from some of the most harmful solar radiation that could come to the ground and give us nasty burns and really heat up the planet. So it's a good shield. But now let's talk about some of the bad ozone, the tropospheric ozone. So of course, not all the oxygen can block all of the solar radiation. So you'll see a little bit of it make its way down here to us at ground level, and it'll run into human-made pollutants, such as VOCs and NOx. Now, VOCs are volatile organic compounds that come from places like your gas tank or unburned fuel coming from your tailpipe and other various industries like consumer products or specialty chemicals. NOx are oxides of nitrogen that actually come from your tailpipe when fuel is burned in your engine. So now that our sunlight has run into this mixture of VOCs and NOx, a chemical reaction is ready to take place that actually forms ozone. And so now we've got what we call ground level ozone. And we call it ground level ozone because you and I can breathe it. And that becomes problematic because ozone is a very highly reactive molecule that gets into your respiratory tract and reacts with molecules in your body. Quite a bit of work has gone into reducing ground level ozone across all industries, and in the transportation industry, one of the most important places that you can actually help fight it is through the fuel. And that actually leads into my favorite fuel parameter, of course, the Reid vapor pressure. Reid vapor pressure, or RVP for short, is actually a measure of the tendency of a fuel to evaporate at 100 degrees Fahrenheit. Or more simply put, it's the volatility of the fuel that you're looking at. It's a good measure of that. So as we go forward, let's consider an example here. It's a hot summer's day, and you decide to take a couple laps around the block, just a quick little walk, and you come across three puddles that are the same size. The first is a puddle of gasoline with no ethanol in it. The second is a puddle of ethanol with no gasoline in it, and the third is a puddle of water. So you continue your walk and you go around a few more laps, and you come back and things have evaporated as you would expect on a hot summer's day. So you come back and you look at your puddles, and water has evaporated maybe this much. Ethanol has evaporated maybe this much, and gasoline has evaporated maybe about this much. So you'll notice that the gasoline puddle is now the smallest. And what we can draw from this is that it is actually the most volatile of all three of the compounds listed. So let's draw our conclusion related to Reid vapor pressure. We would actually expect the Reid vapor pressure of the gasoline to be the highest, and that is the case. When it comes to the pump, it's normally somewhere between 8 and 9 psi. Here I have it listed at 8.4 psi. Now pure ethanol, since the puddle's a little bigger, we would expect it to be a little lower than 8.4 psi. And that's exactly the case. It's actually 2 psi. And then water, of course, being the biggest puddle, should be the lowest RVP, and it is. It's 1 psi. So what all of this means is that with a lower Reid vapor pressure, or RVP, we actually have fewer VOCs that can evaporate out of the fuel, or fewer VOCs that will escape from our gas tanks. And that means that fewer VOCs can mix to create ground level ozone.